Okay, 7.4 Properties of Special Parallelograms. Now I'm going to tell you now there's a lot of writing for this one and then only a few examples. But let's look at this. A lot of these words you might already know, but it's good to see the formal definition of them. A rhombus, a parallelogram with four congruent sides. I always think of a rhombus as a smashed square, right? So it would look something like that. Next up, we have a rectangle, and this is probably one that we already know. It's a parallelogram with four right angles, right? So it's going to look like that. It happens to be, and I think we're going to have that in just a second, that opposite sides of a rectangle are congruent, like this, right? That's a property of a parallelogram and a rectangle there. Next up, we have the word square, a parallelogram with four congruent sides and four right angles. And I think we all know what a square is. So we talked about rectangle, we talked about square. All right, next up we have some corollaries. 7.2, the rhombus corollary. A quadrilateral is a rhombus if and only if it has four congruent sides, right? We know that. That's the definition of a rhombus. But it has this word if and only if, which means we could read it backwards and forwards, right? We talked about that being a biconditional statement. So anytime we have a four-sided figure with four congruent sides, it's going to be a rhombus, right? We could read it backwards and forwards. Next up, 7.3, the rectangle corollary. A quadrilateral is a rectangle if and only if it has four right angles, right? And again, it has this if and only if. That's a biconditional, so we could read it backwards. We could read if it has four right angles and it's a quadrilateral, which means that it's four sides, then it's a rectangle, right? You can read it backwards and forwards. 7.4, the square corollary. A quadrilateral is a square if and only if it is a rhombus and a rectangle, right? And that's worded a little bit differently, but what it's saying is it's basing it off of, see, we have a rhombus, four congruent sides, and a rectangle, four congruent angles, right? It's kind of restating the definition of a square just in a little bit of a different way. It's good to think about a square is like the child of a rectangle and a rhombus together. To show that, we've got a little bit of a picture here, and I like this picture a lot. You don't necessarily have to copy it down, but we have our big box is parallelograms. We know that parallelograms have opposite sides that are parallel, right? Over here we have rhombuses, which have four congruent sides, and here's a couple of pictures of rhombuses. And then we have rectangles with four congruent angles, and here's a couple of pictures of rectangles. And then, what is this, a Venn diagram where it overlaps, that's where we get the square. That's what I said, the square is kind of like the child of the two. All right, let's look at 7.11 or 7.11, the rhombus diagonal theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. Now, perpendicular means 90 degrees, right? They meet at 90 degrees. So let's see if I can draw a little bit of a picture of this. Diagonals, and we've got a right angle in there, right? And I can also put the little tally marks on the sides of it like that. So that would be a rhombus with its diagonals drawn in, and the diagonals meet at a 90-degree angle. 7.12, rhombus opposite angles theorem. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. All right, that one's a little bit harder to see, but let's look here. Let me see if I can draw a picture. So if this is its diagonal, let me draw that a little bit better. If these are its diagonals, then it tells us that the diagonals bisect a pair of opposite angles. So this and this would be equal, and it would also be that this and this are equal, and they're equal to each other. And then we'd have these guys and those guys. Right, so that's what that is saying. And it's an if and only if statement, which means that if we see a picture that's just this, then we can say it's a rhombus. We don't have to be able to have it written that those are all congruent. but it is true that they are congruent, right? Next up, 713, rectangle diagonals theorem. A parallelogram is a rectangle if and only if its diagonals are congruent, right? So what this is saying is that if we have a rectangle, right, we know that those are all 90-degree angles because it's a rectangle, then this guy and this guy are equal. The green equals the blue piece, right? You can see that up in our rhombus that one of those blue diagonals is longer than the other blue diagonal, right? Because it's not a rectangle. This rectangle diagonals theorem, and also the other rhombus ones, those apply to squares as well, right? If we had a square, then its diagonals would be equal. The black would be equal to the purple. And then it would also bisect the angles, right? It would bisect this angle up here to be equal, and it happens to be that they would all be equal, right? And they'd all be 45 degrees because the whole angle is 90. So this little piece here would just be 45 degrees. Okay, some neat things that we should know. All right, let's look at some examples. Here, let me scroll back up, and you can pause if you need to while you look at those. All right, example number one. For rhombus JKLM, decide if the statement is always or sometimes true. JM equals KL. So let's draw a picture here so that I can know about what I'm doing. So we've got J, K, L, M. And what it's wanting us to decide is if JM is equal to KL. Well, a rhombus, we know that a rhombus by what, I think we can just say by definition. A rhombus, the definition is a parallelogram with 4 congruent sides. So yeah, or we could also look at the rhombus corollary, 7.2, has 4 congruent sides. So yes, JM will always be equal to KL, so always. Okay. Let's look at number 2. Find each angle. The figure is a rhombus. Well, we know that by one of those theorems up there. I don't remember what it was. Let's look at what it is. (712). So this we're going to use 712. That's the angle bisect. 7.12 is the angle bisecting piece, where we know that, let me write this in here, this guy and that guy are equal, this guy and that guy are equal. Then I can also say that this one and this one are equal, this one and that one are equal. Okay, so really quickly, I can say, well, measure of angle 1 is equal to measure of angle 2 is equal to measure of angle 4, which is equal to 27, right? That one should be pretty easy for us to see. So I took care of this one, this one, this one. Next up, I have the 6 and the 5. I know that measure of angle 5 is equal to measure of angle 6, right? Because they're, well, I've marked them as equal. I know that everything adds up to 360 here, right?
Teachers and staff, we will leave at 8:15 a.m. Some teachers do not get here until 8:15, so we'll wait until everyone's here before we eat. Again, we'll eat at 8:15. Thanks.
All right, sorry about that. Let's find this whole angle here. And the way that I can do that is I can say that we've got 180 minus 2 times 27 degrees. All right, so looking right here, what I've written there is 180 minus 2 times 27. The 2 times 27 gives me angle E here. And I know that consecutive angles, angles that are next to each other, are supplementary, which means they add up to be 180. So I'm taking 180 minus 2 times 27, and whenever I type that in, 180 minus 2 times 27, I get 126. Is that right? Yeah, 126. Right, so that's that would be equal to measure of angle 6 plus measure of angle 5, right? It would be both of them. So now I'm going to divide by 2 so that I can get the individual angle. So now I have, what is this, 63 is measure of angle 6 equals measure of angle 5. So let's write that over here, 63 degrees, okay? So let me see if I can erase that blue marking there. So I've taken care of now 6 and 5. My only one that's left is measure of angle 3. And let's scroll up and see if we have anything up here that will help us out. 7.11, rhombus diagonals theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So its diagonals meet at a 90-degree angle. So in this picture here, angle 3 would be 90 degrees. And that's it. We have all of our angles listed. Now on your homework, you're going to have some that have a bunch of them that are going to be equal. I suggest you write it the way that I have, that all these angles are equal. You could write them all out, like measure of angle 1 is 27, measure of angle 2 is 27, measure of angle 4 is 27. This is just the shorthand way to do it, and this is the way that I like to do it. So let's move on and let's look at number 3. WXYZ is a rectangle. Solve for X. Well, let's draw a picture and let's see what this is talking about. WXYZ. WY is this, it's a diagonal. And then XZ is a diagonal. Now I believe that we know that diagonals in a rectangle are equal. Let's see which theorem that is. That's 7.13, the rectangle diagonals theorem, right? The diagonals are congruent. So right here, I know the diagonals are congruent, so their measurements are going to be equal. So I can say 6x minus 7 equals 3x plus 2. Solving this, I'm going to get, what will I get? 3x is 7, 8, 9. So x is going to be 3. Alrighty? Pretty easy, or at least hopefully so. And then we just want to remember, what does it mean to be similar? I think there's going to be one problem asking about our rhombus is always similar, I think. I don't know if that's the specific one, but to be similar, they have to have congruent angles and proportional, and I'm not going to spell that wrong. Proportional sides, okay? Those are the two requirements. So if we're saying that two triangles, we'll talk about triangles. We'll say that all three of these angles are equal and they're 60 degrees, and then we have another triangle over here with the same equal side measurements, or equal angle measurements. And we'll say that this is 1, 1, and 1, and this one's 2, 2, and 2. They are proportional because you could multiply the left one by something, being 2, and get the right one, right? It's 2 times in size. So the two things that you have to check are angles and sides. Are the sides proportional? So if we're thinking about a rhombus, you could make a rhombus. Oops. We can make this rhombus, right? That's a rhombus. It happens to be a square also. Or you could make this rhombus, where the angles are obviously not equal, right? So not all rhombuses are similar, and I think that's what the homework problem is about. So that's something good to think about, something good to know, something good to recognize. So that is that. Let me scroll back up and look at all these again. Again, most of these words we probably know, but it's good to have them written down. It's good to have them actually the final definition, or the formal definition. I think the ones that we will most often use are these 3 theorems here, 11, 12, and 13. So make sure that we have these written somewhere. Alrighty, that's all.